Hello, my dear students. Good evening. Thank you for subscribing my channel. Can I start the class? Given if an electron has spin quantum number of plus half and magnetic quantum number of minus 1, then it cannot be represented. Spin quantum number is given as plus half. We know that spin quantum number is not depends on any other quantum numbers, and magnetic quantum number is given as minus 1. It cannot be s orbital. Why? Because s orbital L value 0, possible m value is 0, because m values are from minus L to plus L including 0. For example, p orbital you can consider p orbital L value 1, m values, possible m values are minus 1, 0, plus 1. Yes, p orbital case m value minus 1 is possible. D orbital L value 2, m values are minus 2, minus 1, 0, plus 1, plus 2. Yes, d orbital case also magnetic quantum number minus 1 is possible. F orbital L value is equals to 3, possible m values are minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Magnetic quantum number of minus 1 is possible. Minus 1 is not possible in case of s orbital. Dipole moment of HF is greater than H2O. Wrong. HF dipole moment value is 1.78. H2O dipole moment value is 1.85. HF is less than H2O. Assertion is wrong. HF bond is more HF bond is more polar than OH bond. Correct. HF bond is more polar than OH bond because fluorine is more electronegative atom compared with oxygen. A is false, R is true. The next question. A gaseous mixture contains CH4 and C2H6 in equimolar proportions. The weight of 2.24 liters of this mixture at STP is given equimolar proportions, means both are in equal amounts. You can take 1 mole of CH4 and 1 mole of C2H6. Total number of moles 2 moles. 1 mole of any gas occupies 22.4 liters. 2 moles occupies 44.8 liters. 1 mole of CH4 weight 16 grams. 1 mole of C2H6 weight 30 grams. Total 2 moles weight is 46 grams. Now, relation between weight and volume. 44.8 liters of the mixture weight is 46 grams. Then 2.24 liters of the mixture weight is question mark. Simplify cross multiplication technique. 2.24 into 46 divides with 44.8, that is equals to 2.3 grams. Third option is correct option. In which of the following reaction the underlying substance has been reduced? Underlying substance is CO. CO converted to CO2 plus 2 oxidation state is converted to plus 4. Oxidation takes place. Question is reduced. So first option wrong. Second option, underlined substance is CuO. CuO converted to CuCl2 In CuO, copper oxidation state is +2. CuCl2 copper oxidation state is +2. Neither oxidized nor reduced. Second option also wrong. Third option, underlined element is H2O. H2O converted to H2. In H2O, hydrogen oxidation state is +1. In H2, hydrogen oxidation state is 0. +1 to 0. Reduced. Correct option is third option. Fourth option, carbon converted to CO2. Here also oxidation takes place. The product P in the following reaction is alkyl halide reacts with aqueous KOH. Nucleophilic substitution takes place. Substitute the nucleophile CH3, CH2, OH. The alcohol is 1 degree alcohol. 1 degree alcohol reacts with PCC. PCC is present. Partial oxidation process takes place. 1 degree alcohol are converted to aldehydes. Reacts with LiAlH4 H2O. Then reduction process takes place. Aldehydes undergoes reduction. Then it gives alcohols. It gives CH3 CH2OH. P is ethanol. Ratio of rate constants K2 by K1 of a chemical reaction at two different temperatures T1 and T2 is 10. K2 by K1 ratio is given 10. Activation energy value is given as 4.606 calories. Activation energy value is given in terms of calories. So R value is also taken in terms of calories. At two different temperatures, activation energy is calculated by using the equation log K2 by K1 is equals to VA by 2.303 T2 minus T1 by T1 into T2. So substitute the values log of K2 by K1 value is 10. Activation energy value is 4.606 by 2.303 into 2 T2 minus T1 by T1 into T2. 4.606, 4.606 cancel. Log 10 value is 1. 1 is equals to T2 minus T1 by T1 into T2. Do the cross multiplication. Then you will get T1 into T2 is equals to T2 minus T1. Correct option, fourth option. The crystal field splitting energy of octahedral complex is 18,000 centimeter inverse. Then crystal field splitting energy of tetrahedral complex is, the relation between tetrahedral complex and octahedral complex is delta T is equals to 4 by 9 delta naught. 4 by 9. Crystal field splitting energy of octahedral complex is 18,000. Substitute 18,000. Do the calculation. Then you will get 8,000 centimeter inverse. Second option is correct option. Select correct combination. Chromate ion color is yellow color. Dichromate ion color is orange color. Correct. Manganate ion color is green color. Manganese dioxide color is black color. So all are correct. A, B, C, D is correct. Cane sugar plus H2O gives rise to glucose plus fructose. What is the final product of reduction of above glucose? Glucose is reacts with HI. Then it gives N-hexane. Based on this, in glucose, all carbon atoms are arranged in straight chain form. N-hexane, correct answer. Which of the following transition metal is present in Mishk metal? Mishk metal, in Mishk metal, lanthanide metal percentage is 95%. Iron percentage is 5%. Traces of sulfur, carbon, calcium and aluminum is present. Transition metal. Which transition metal is present? Iron is present. The most stable canonical structure among the following is. Third structure is most stable canonical structure. How? 1 and 2 incomplete octet. How? How it is incomplete octet? Because carbon atom bearing the positive charge. Positive charge is present on carbon atom. Generally, around carbon 4 bonds are present. That means it follows octet. But in this structure, carbon contains positive charge. When carbon contains positive charge, carbon contains positive charge if carbon loses pair of electrons. Suppose carbon loses pair of electrons. Around carbon, 6 electrons are present. 3 bonds or 6 electrons are present. Those two structures will not follows octet rule. So first one is unstable as well as second one is also unstable. Third one is stable. How? Generally, around oxygen contains two lone pair of electrons. But in the given structure, oxygen contains a positive charge. Oxygen contains positive charge. That means oxygen loses a pair of electrons. If oxygen loses pair of electrons, then one around oxygen atom, 1, 2, 3 bonds and one pair of electrons are present. And one pair of electron is present. So total pairs, 4 pairs of electrons. 4 pairs of electrons means 8 electrons are present. It follows octet. So third structure is most stable structure. Wrong match is cellulose acetate, semi-permeable membrane in the reverse osmosis. Correct. 90% N2 respiratory kit in scuba diving. No, the percentage of N2 is 56.2%. So wrong match is second one. Third one is correct. Even fourth one is also correct. Cn minus plus H2O gives rise to HCN plus OH minus. K value is 10 power minus 9. Then equilibrium constant for the neutralization of HCN with strong bases. For neutralization, equilibrium constant is calculated by using this formula. K neutralization is equals to 1 by K1. The K1 means given value of K. 1 by given value is 10 power minus 9. That is equals to 10 power 9. Correct option is third option. Given below are two statements. Statement 1. Naphthalene is non-benzenoid compound. This is the structure of naphthalene. Naphthalene contains benzene rings. Two benzene rings combination is considered as naphthalene. So benzene ring is present. This is considered as benzenoid. So statement 1 is wrong. Benzene molecule contains 12 planar atoms. We know that. In case of benzene formula is C6H6. Every carbon atom undergoes sp2 hybridization. sp2 hybridization geometry is planar. So planar atoms, 6 hydrogen atoms are planar as well as 6 carbon atoms are also planar. 6 hydrogens plus 6 carbons, total 12 atoms. Statement 1 wrong, statement 2 correct. The correct structure of X is, remember, Br2 in the presence of sunlight, NCS, NBS, SOCl2. NCS means N-chlorosuccinamide. NBS is N-bromosuccinamide. All these reagents favors allylic or benzylic substitution. Favors allylic or benzylic substitution. So substitute bromine atom at allyl carbon. Here, this is allyl carbon, this is also allyl carbon. Any one place you can substitute bromine atom. Based on that, second option is correct. The IUPAC name of the following compound. Here two functional groups are present. One is amide functional group and the second one is aldehyde functional group. Among amide and aldehyde, which is high priority group. Amide is present here, aldehyde is present here. So amide is high priority group. Starts with amide carbon. Numbering starts with amide carbon. 1, 2, 3, 4, 5, 6. At second position, a branch is present that is methyl group. 2-methyl. Name starts with 2-methyl. Only one option. 2-methyl 6-oxo. Aldehyde is taken as a substituent. So use oxo. 6-oxo hex 3-enamide. Identify the product. PCC. Partial oxidation takes place. PCC, PDC, CrO3, all these cases, partial oxidation process takes place. If it is 1 degree alcohol, 1 degree alcohol is converted to aldehyde. 2 degree alcohols are converted to ketones. 3 degree alcohols does not react with PCC because PCC is a partial oxidizing agent, weak oxidizing agent. That's the reason 3 degree alcohols does not react. Now identify OH group attached carbon directly attached to one carbon. So it is 1 degree alcohol. 1 degree alcohol is converted to aldehyde. OH group attached carbon directly attached to two other carbons. So this is 2 degree alcohol. 2 degree alcohol is converted to ketone. Based on that, correct answer is third option. Alkene plus HCl in the presence of peroxide. What is the product? Remember, very important. HBr peroxide only follows anti-Markovnikov's rule. HBr peroxide only follows anti-Markovnikov's rule. Except HBr peroxide, remaining all cases, it follows Markovnikov's rule. In case of Markovnikov's rule follows electrophilic addition mechanism. Reaction intermediate is carbocation. Order of stability of carbocation is 3 degree greater than, 2 degree greater than, 1 degree. Order of stability. So based on that, this is 2 degree carbocation. This is 1 degree carbocation. 2 degree carbocation is more stable. Third option correct. At room temperature, allotropy is not exhibited by nitrogen. Condition is at room temperature. At room temperature, nitrogen does not exhibit allotropy. CH3COOH reacts with the B2H6. Reduction takes place B2H6. If reactant is carboxylic acid, reduction takes place and it gives alcohol. The alcohol is CH3CH2OH. Which type of alcohol this is? 1 degree alcohol. 1 degree alcohol, we know that 1 degree alcohol, copper 573 kelvins, aldehyde is the product. 2 degree alcohol, copper 573 kelvins, ketone is product. If it is 3 degree alcohol, copper by 573 kelvins, then alkene is the product. Copper 573 kelvins, dehydrogenation process takes place. It is 1 degree alcohol. 1 degree alcohol is converted to aldehyde. Aldehyde is a carbonyl compound. Carbonyl compounds reacts with 1 mole of alcohol, then it gives hemiacetal. If it reacts with 2 moles of alcohol, then it gives acetal, because carbonyl compounds are more favorable towards nucleophilic addition reactions. Incorrect statement about XeF4. It has square planar shape, correct. 2 lone pairs, correct. Undergoes sp3d2, correct. Incorrect statement. It is polar molecule is incorrect. It is a non-polar molecule. Because two lone pairs are exactly opposite direction, resultant dipole is cancel with each other. Correct order of basic strength in aqueous medium. Yes, in aqueous medium. In aqueous medium, if alkyl group is methyl group, order of basic nature 2 degree greater than, 1 degree greater than, 3 degree greater than ammonia. If it is ethyl group, order of basic nature 2 degree greater than, 3 degree greater than, 1 degree greater than. So identify first of all, ethyl group is present, ethyl group is present, ethyl group is present. This is 1 degree amine, this is 2 degree amine, this is 3 degree amine. Okay. And basic nature is directly proportional to size of the alkyl group. Second option, size is alkyl group is methyl, so B is least. Correct option is second option. Identify X in the following reaction. First of all, this is methyl ketone. Methyl ketone reacts with NaOH plus X2O or NaOX. NaOX. Then it gives haloform. This reaction is called as haloform reaction. In this, the product methyl ketones are undergoes oxidation. The product contains 1 carbon atom less compared with reactant. Why 1 carbon atom is less? Because break the bond here. This is converted in the form of haloform, remaining CH3, CH double bond CH, CH2, C double bond O, ONA. First option correct option. Remember, in haloform reaction, salt of carboxylic acid contains 1 carbon atom less compared with the reactant. For the reaction, equilibrium mixture contained 3 moles of 3 moles each of PCl5, PCl3 and Cl2. If the total pressure is 3 atmosphere, what is the value of Kp? for the reaction. What is given? At equilibrium, 3 moles of each substance is present. Calculate Kp. Kp is equals to formula P partial pressure of PCl3 into partial pressure of Cl2 by partial pressure of PCl5. Partial pressures are not given. Here total pressure is given. Total pressure is 3 atmosphere. First calculate partial pressure of PCl5. Partial pressure of PCl5 is equals to total pressure 3 into mole fraction of PCl5. Mole fraction of PCl5, number of moles of PCl5 by total number of moles, 3 plus 3 plus 3, 9. Partial pressure of PCl5 1, partial pressure of PCl3. It is also 3 into 3 by 9, 1. Partial pressure of Cl2, 3 into 3 by 9 by 1. Kp value is 1. First option correct. Day 2 bond is absent in Day 2 bond is absent in NH4Cl. In Al2Cl6, Day 2 bond, two Day 2 bonds are present. C3O2CO also, according to old chemistry, if surrounding atom is oxygen, then in the molecule a Day 2 bond is present. Identify the product A and B in the following reaction. Alcohol concentrated H2SO4, dehydration takes place. Major product follows Sage-Jeff's rule. Sage-Jeff's rule. What is Sage-Jeff's rule? Remove hydrogen atom from beta carbon which contains less number of hydrogens. This is beta, this is beta, this is also beta. Remove hydrogen from beta carbon which contains less number of hydrogens. So this is the product. CH3CO minus K plus. It is a bulky base. Dehydrohalogenation in the presence of bulky base gives Hoffman product as a major product. Remove hydrogen atom from beta carbon which contains more number of hydrogens. Based on that, first option is correct option. Assertion. CO, C2O4 taken thrice 3 minus, complex is inner orbital complex with diamagnetic. Correct. C2O4 2 minus is a strong field ligon in CO3 plus. This is also correct. In cobalt complexes, oxalate ion acts as strong ligand field. A is true, R is true, R is the correct explanation for A. Identify based on N1, N2 values, identify the color. Electron jumps from 3 to 2, that is smallest energy gap. For example, you can check N is equals to 1, N is equals to 2, N is equals to 3, N is equals to 4. First case, electron jumps from 3 to 2. Next case, electron jumps from 4 to 2. Next case, electron jumps from 5 to 2. After that, electron jumps from 6 to 2. So 3 to 2, smallest energy gap, 6 to 2, highest energy gap. We know about Wibjar. We are moving from violet to red, wavelength increases, energy decreases. So red energy is less, violet energy is more, Based on that, fourth option is correct option. Both lanthanum and actinium are D block elements. Identify correct statement. Yes, lanthanum and actinium are D block elements. In lanthanides, europium has largest atomic radius. This is also correct. Chlorine forms strong acidic oxides. Correct. Among silicon, beryllium, magnesium, sodium, and phosphorus, the most metallic is magnesium is given. We know that metallic character, periods left to right, periods left to right, metallic character decreases. This statement is wrong. Correct option is third option. The reduction potential of hydrogen electrode when platinum wire is dipped in 0.001 molar HCl and hydrogen gas at 10 atmosphere is passed around platinum is, according to given data, standard hydrogen electrode equation. This is standard hydrogen electrode equation. We know that for standard hydrogen electrode, SRP value, standard reduction potential value, is 0, and in this equation 2 electrons are involved. Now E is equals to 0 minus 0.0591 by 2 log of product is H2 gas, reactant is H plus ion. How many moles of reactant is present? 2 moles. Now calculate this value. Log of H2 by H plus whole square. Log of H2. H2 is a gas. Gaseous pressure is given as 10 atmosphere by H plus concentration 0.001 molar means 10 power minus 3 molar. 10 power minus 3 whole square. 10 power minus 3 whole square, this is 10 power minus 6. Log of 10 by 10 power minus 6 log of 10 power 7. 7 log 10 and the value is 7. E is equals to minus 0.0591 into 7 by 2. Simplify, you will get minus 0.20685. Nearby answer is third option. Specific conductance of 0.04 molar KCl is greater than that of 0.04 molar CH3COOH. Yes, this is correct statement. How? KCl is a strong electrolyte. Strong electrolytes are 100% ionizable. So number of ions per unit area increases. But CH3COOH is weak electrolyte, not 100% ionizable. So for strong electrolytes, specific conductance is more compared with weak electrolytes. Increase in molar conductance with dilution is more in 0.04 molar CH3COOH than in 0.04 molar KCl. Statement 1 is correct. Statement 2 is also correct. Statement 1 is about specific conductance. Statement 2 is about molar conductance. Incorrect about bonding in metal carbonyl is incorrect statement. Read this para. First statement correct, second statement correct, third statement is also correct, fourth statement is incorrect statement. Why? See here, metal to ligand bonding, but here what is given? Ligand to metal bonding. That's the reason this is incorrect. Which of the following pairs of oxides both are amphoteric? Both are amphoteric. Cr2O3 and V2O5 are amphoteric. Oxygen is more electronegative than sulfur, yet H2S is more acidic than H2O. Correct statement. Because here acidic nature is not depends upon electronegativity. In the case of hydrides case, acidic nature is directly proportional to MH bond length. HS bond is weaker than OH bond. Correct. A is true, R is true, R is the correct explanation for A. Match the following. Adiabatic process. Heat remains constant. 1 is 2. Isothermal process. Temperature remains constant and internal energies also remains constant. Fourth option, correct option. Isobaric process, pressure is constant, remaining are not constant. Isochoric process, volume constant, work done is calculated by using the formula minus P delta V minus P into 0, then work done is equals to 0. Consider the following statements. Incorrect statement. Consider the following statements. Incorrect statement is BCl3 is Lewis acid. Correct. Strong acid have very strong conjugate base. Wrong. Why? According to conjugate acid base pair theory, strong acids form weak conjugate base. Third, C statement. According to Bronsted-Lowry theory, in an acid-base reaction, equilibrium shifts from strong acid to strong base to weak acid weak base. Correct. Only 2 is incorrect statement. Solutions of NaCl labeled as A with concentration 0.1, B with concentration 0.01, C with concentration 0.001 respectively. Condition is given alpha less than 1. The value of Van 't Hoff factor for this solution will be Van 't Hoff factor. Concentration decreases, then Van 't Hoff factor value increases. Based on that, which Van 't Hoff factor value is more? IC. Third option. Incorrect among the following. First one is only incorrect because aluminum electronic configuration is neon 3s2 3p1. Al plus 1 electronic configuration is neon 3s2. Al3 plus electronic configuration is neon. We know that noble gas electronic configurations are more stable electronic configurations. The salt solution of X gives a white precipitate with BaCl2 solution. The precipitate is soluble in diluted HCl. The anion is carbonate ion. How? See, nitrate ion, barium nitrate is soluble in water, not soluble in HCl. I minus is soluble in water, not soluble in BaCl2 solution or HCl solution. SO4 2 minus forms white precipitate with BaSO4, but this precipitate is insoluble in dilute HCl. CO3 2 minus forms white precipitate and it is soluble in dilute HCl. Potassium ferrocyanide solution is not used for the detection of Fe2 plus. It is used in the detection of Zn2 plus, Cu2 plus and Fe3 plus. For Fe2 plus, we are using potassium ferricyanide instead of potassium ferrocyanide. Use potassium ferricyanide. The rate constant of a first order reaction is given. What is the time? Calculate the value of time. Initial and final concentrations are given. Now substitute 2.303 by 0.0693 log of R naught initial concentration is 40, final concentration is 5. How many times? 8 times. Log 8 value is calculated 0.9030. 2.303 into 0.9030 by 0.0693. By you will get 30. Heat of solution and hydration of MgSO4 are minus 70 kilojoules and minus 84 kilojoules respectively. The heat of solution of MgSO4.7H2O. This is hydrated solution. Enthalpy of hydrated solution is equals to enthalpy of anhydrous solution minus enthalpy of hydration. Formula. Enthalpy of anhydrous solution MgSO4. Anhydrous solution is minus 70 minus enthalpy of hydration value is given as minus 84. Minus 70 plus 84, you will get plus 14. Third option is correct. C6H5 N2Cl is more stable than C2H5 N2Cl. Correct. Why? C6H5 N2Cl, it is aromatic diazonium salt. This is aliphatic diazonium salt. Aromatic diazonium salts case resonance is possible. Resonance is present, stability increases. Based on that, C6H5N2 plus can be stabilized through resonance, whereas C2H5N2 plus cannot be stabilized by resonance. A is true, R is true, R is the correct explanation of A. Which gives positive Fehling's test. Which gives positive Fehling's test? Only aliphatic aldehydes. In this, identify aliphatic aldehydes. Acetaldehyde is a aliphatic aldehyde. Methanol is a aliphatic aldehyde. Cyclohexane carbaldehyde is a aliphatic aldehyde. Remaining are aromatic aldehydes as well as ketones. Aromatic aldehydes and ketones does not give positive Fehling's test. To dibromopropane on treatment with X moles of NaNH2 followed by treatment with C2H5Br gives pentane. This is the reactant and this is the product. What is the value of X? First of all, NaNH2 acts as dehydrating agent as well as NaNH2 easily reacts with acidic hydrogen. Here two bromine atoms are present. So first of all, you can use 2 moles of NaNH2. Dehydrohalogenation 2 times takes place. Then it gives CH3 triple bond CH. Acidic hydrogen is present. Acidic hydrogen is present. Again use NaNH2. Ammonia gas is eliminated and it is converted to CH3 triple bond C Na. C minus Na plus. John further reacts with the C2H5Br. Remove NaBr, 3 triple bond C, CH2, CH3. Pentane is formed. How many moles of NaNH2 is used? Here 2 moles, here 1 mole. Total number of moles 3 moles. Thank you.